Directorate, and we're going to start this talk not by me giving a huge bio. Of course, you can read up on Catherine and her extensive bio, but with a short video. So please sit back and enjoy this keynote speech.
Just the starting point.
Ladies and gentlemen, your Artemis.
On the journey that gets humanity to Mars.
On behalf of all the men and women across our great nation who have worked to make this day possible, I give you a go to launch Artemis 1.
For the first time in 50 years, we were breaking out of low Earth orbit to head toward the moon.
We are putting something that we dreamed about into reality.
It sent a message really to the world that we have laid the foundation for a generational rocket.
How many times in your career do you get to be a part of a first?
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
For Artemis, this is just the starting point.
Ladies and gentlemen, your Artemis 2 crew.
Thank you to the NASA workforce. Thank you to our industry partners, everyone in Europe that's working for this.
America has made a very deliberate choice to curate a global team, and we are going to the moon together.
We need to celebrate this moment in human history. It is the next step on the journey that gets humanity to Mars.
Am I excited? Absolutely.
We're going to test out the vehicle's ability to conduct rendezvous maneuvers, the crew's ability to actually fly Orion manually, and most importantly, we're going to test the environmental control system. We got humans on board. We got to keep them safe. We got to keep them breathing. And then we're going to have them come back at that high-speed entry of 32 times the speed of sound to make sure that they can survive this for future missions.
And so we have new launch commit criteria, we have changes to our procedure, changes to our timelines.
We have new systems for crew, we have new systems in the capsule, we have an emergency egress system.
By building incrementally these capabilities, improving these capabilities that we have, we will be able to live on the moon and be able to perform science for deep space exploration.
I am ready for Artemis 2. The SLS team is ready for Artemis 2.
We are ready for Artemis 2.
We are ready.
We are ready.
All right, I'm ready. Let's go.
On behalf of all the men and
Thank you for the invitation to join you in Luxembourg this year at the Space Resources Week. As we discuss the future of space exploration, Luxembourg was one of the very original signatories of the Artemis Accords in 2020. Many of you here today are already involved in Artemis through international and commercial partnerships. Thank you for your unwavering perseverance, passion, and dedication to the Artemis campaign. As you heard, I am Kathy Koerner. I'm the Associate Administrator for Exploration Systems Development at NASA headquarters, and it really is an honor to be joining you today. The Artemis missions are different than anything humanity has attempted before. Building on the success of the International Space Station, NASA and our partners are working towards establishing a sustainable infrastructure for long-term exploration in lunar orbit and on the surface. The infrastructure will facilitate ongoing scientific research for discovery and for the benefit of humanity. Having humans live and work on and around the moon presents a very different challenge than what we have currently on board the International Space Station. ISS is only about 350 kilometers from Earth. If needed, we can relatively quickly get critical life-sustaining supplies and hardware to the space station and return our astronauts home if we need to. The moon, as you know, is more than 1,000 times farther away, about 386,000 kilometers. And when astronauts eventually reach the Gateway, our lunar space station, they'll be up to 70,000 kilometers away from even the moon. Artemis generation astronauts will be far, far from home, and that means we have to develop new approaches to supporting them. In situ resource utilization, or ISRU, is a critical piece of the puzzle for enabling sustainable, long-term exploration for this new generation of explorers. Successful long-duration exploration missions to the moon and Mars will require collecting, processing, and storing and using materials found or manufactured at these destinations. Water ice is perhaps the most critical resource on the moon. Thanks to past missions, such as NASA's Lunar Reconnaissance Orbiter and others, we know that there is ice at the lunar's south pole's permanently shadowed regions, some of the coldest spots in the universe. When we can extract and use these resources, we will be able to produce drinking water, generate breathable oxygen, and manufacture rocket propellant directly on the lunar surface. NASA's Artemis lunar rover, the Volatiles Investigating Polar Exploration Rover, or VIPER is much easier to say, will land at the lunar South Pole for a 100-day mission. The critical information VIPER provides will teach us about the origin and the distribution of water on the moon and help determine how we can harvest the moon's resources for future space exploration. NASA will use the data the rover collects to show where the moon's ice is most likely to be found and easiest to access. VIPER will roam the lunar surface using 3 instruments and a 1-meter drill to detect and analyze various soil environments at a range of depths and temperatures. VIPER's instruments will also make important scientific measurements. Determining the composition of these ice deposits will help us understand the sources of lunar polar ice, giving us insights into the distribution and origin of the water and other volatiles across the solar system. Lunar regolith is another important resource containing materials, minerals, and metals that can be processed and used in construction, manufacturing, and radiation shielding. NASA is actively exploring techniques to extract and refine regolith into building materials such as bricks and concrete for construction of habitats, landing pads, and other infrastructure to facilitate a sustained lunar presence. NASA's ISRU pilot excavator, or IPEX, which will fly on a commercial lunar payload services mission, will demonstrate excavation of up to 10 metric tons of regolith on the moon. By improving ISRU technologies, astronauts aim to establish an infrastructure that supports extended crewed missions and reduce our dependence on Earth for essential supplies and serve as a stepping stone for future human exploration of Mars. Through technology development and partnerships, multiple nations and companies will play a pivotal role in unlocking the economic, scientific, and exploration potential of lunar resources. Together, we can harness today's rapidly advancing technologies and conceive of innovations for tomorrow. Together, we can chart a path towards thriving lunar economy and a sustainable human presence beyond Earth. Our Artemis 1 mission, which flew just a little over a year ago, was an essential first step in Artemis campaign and our efforts to establish long-term presence at the moon. There we go. This is a picture from the Artemis 1 test flight. The launch and the landing, as well as the entire mission, were about as picture perfect as they possibly could be. The Artemis 1 flight set new performance records exceeding our standards for efficiency and establishing new safety baselines for human spaceflight in deep space. Artemis 1 was the first in a series of increasingly complex missions that will expand the bounds of human exploration. Ultimately, we are building the foundations of an architecture that will allow our children or our grandchildren to set foot on Mars. The Artemis missions are critical to our broader Moon to Mars architecture. When most people think of an architecture, they envision the physical spaces we inhabit, like this building, for example. NASA's Moon to Mars architecture is not a mission, it's not a manifest, or a set of requirements. Instead, it's a blueprint that defines and ties together the elements needed for long-term human-led scientific discovery and deep space. The architecture today consists of 4 segments that grow in complexity and potential for discovery as we incorporate lessons learned and build up infrastructure on the Moon that will advance our capabilities and take us ultimately to Mars. As we proceed through these segments, we seek to fill gaps in the architecture, identifying and building the technologies and the capabilities needed for human exploration. The Human Lunar Return segment will see the first footprints on the lunar surface since Apollo. Foundational exploration will see enhanced lunar mobility and enhanced scientific opportunities. Sustained lunar evolution will see humanity maintain a long-term presence on the Moon, conducting more advanced science and growing a lunar economy. Humans to Mars will establish human presence and exploration of Mars. And as we accomplish our exploration objectives, new segments will be added to the architecture. Last November, we completed our second annual architecture concept review. This internal NASA review is focused on identifying the foundational decisions needed for a crewed mission to Mars and adding more detail about how we break down our objectives for long-term lunar exploration and specific architectural elements that eventually will help us achieve that Mars activity. We also began to define opportunities for new programs and projects that close capability gaps. Last month, we published updates to NASA's architecture definition document, or what we call the ADD, as well as white papers highlighting critical results from the most recent strategic analysis cycle. The updates include current partnerships, identified gaps, and present opportunities for future collaboration. So whether you represent a space agency or industry or academia, there is plenty of work to be done in Artemis. And all of those opportunities are spelled out and rooted in the ADD. I invite you to become familiar with these documents if you haven't already by scanning the QR code. Take a look at what we're doing and what's being done by others and see how your organization might fit in with Artemis. We've talked about the future. Now let's talk about where we are with the next Artemis missions that will get us to that future. Since the successful test flight of Artemis 1, we have been diligently working on lessons learned and preparing for Artemis 2, where NASA's Reid Wiseman, Victor Glover, Christina Cook, and the Canadian Space Agency's Jeremy Hansen will venture around the Moon. Artemis 2 will be the first crewed test flight, a 10-day lunar flyby mission, and that will test Orion spacecraft and life support systems to provide the capabilities and techniques required to thrive in deep space. As we prepare to fly on these missions, safety continues to be our top priority. That's why, as we analyzed the results from Artemis 1 earlier this year and assessed our progress towards Artemis 2, we made some changes. In the interest of crew safety and to give all of our teams time to work through the challenges associated with complex first-time operations and development, we adjusted the planned launch date to September of 2025. As you can see, we're making steady progress toward being ready to fly Artemis 2, and we've gone even further than we show here in these slides. When we take these photos, we have to put them in our PowerPoint, but we continue to make progress on our spacecraft as well. The Artemis II crew and teams at NASA's Exploration Ground Systems, or EGS program, successfully completed the first in a series of integrated ground systems tests at NASA's Kennedy Space Center in Florida. We also recently mated the crew and service module at Kennedy. Teams at NASA's Michoud facility in New Orleans have joined all 4 of the RS-25 engines into the core stage for SLS rocket. The EGS team at Kennedy conducted performance testing of the emergency egress system. Since we have crew on board now, we have to have an emergency egress system from the launch pad. And they completed a series of basket drops to verify the braking system. At NASA's Marshall Space Flight Center in Alabama, the Orion stage adapter is in final integration, and the docking target that will be used for proximity operations has also been installed. The crew participated in diver training at our neutral buoyancy laboratory and practiced procedures to exit the Orion spacecraft in an emergency. During underway recovery test number 11 in February, the EGS landing and recovery team successfully demonstrated recovery procedures utilizing the crew module test article off the coast of San Diego, California. This was the first at-sea recovery training with the Artemis II crew. NASA test directors have also completed a series of terminal count and cryogenic systems in preparation for launch. Artemis III will mark humanity's first return to the lunar surface in more than 50 years, including the first woman to walk on the moon. The Artemis III crew will conduct science experiments to learn more about the moon's South Pole region, a place unexplored by humans, before returning home safely to Earth. In January, we announced the new launch date for this mission to be September of 26. For Artemis III, that aligns with the updated schedule for Artemis II and ensures the agency can incorporate lessons learned from Artemis II into this next mission. The adjusted launch date of September of 26 will also give our industry partners additional time for development, testing, and refinement of the systems ahead of their mission. 2 weeks ago, you may have seen SpaceX conducted their 3rd flight test of the Starship rocket in order to advance the maturity of key systems and processes that will be needed for the Starship human landing system that will land Artemis III astronauts on the moon. Last fall, NASA astronauts Nicole Mann and Doug Wheelock participated in a test of subscale mock-up elevator for the Starship. This elevator will transport equipment and the crew from Starship's habitable area, which is located way at the top of their landing system, all the way to the lunar surface. Wearing spacesuits that simulated the size and the mobility constraints that they'll face on the moon, the crew provided feedback on the elevator, the controls, the available space for cargo, and dynamic operations while the basket moved along a vertical rail system along the landing system. SpaceX and NASA recently performed full-scale qualification testing of the docking system that will connect the Starship human landing system first to Orion and then later to Gateway in lunar orbit. The testing conducted at NASA's Johnson Space Center in Houston included more than 200 docking scenarios with various approach angles and speeds. Additionally, the Artemis III launch vehicle stage adapter is in final phase of integration and assembly. Integration and testing of the Artemis rover Viper that I mentioned earlier is also well underway. All of its instruments have been integrated onto the rover. NASA astronauts are also practicing using lunar tools to perform geology tests while wearing spacesuit prototypes during simulated moonwalks at a rock yard at the Johnson Space Center and at the Neutral Buoyancy Laboratory. Artemis IV. Artemis IV will include the first crewed mission to the Gateway Lunar Space Station, as well as the first deep space logistics flight to the Gateway, and a crew to the lunar surface for exploration and scientific discovery. It is certainly a very ambitious mission. The larger and more powerful version of the SLS rocket, known as Block 1B, is also set to debut on this mission. Gateway will take shape when its first 2 modules, the power and propulsion element, or what we call PPE, and the habitation and logistics outpost, HALO, are connected on the ground and launched aboard a SpaceX Falcon Heavy rocket. The elements will take about a year to reach the near rectilinear halo orbit, or NRHO, relying on solar electric propulsion and the gravity of the Earth, Moon, and Sun in order to slowly spiral out to its destination. As the powerhouse of Gateway, PPE will generate 60 kilowatts of electrical power for Gateway's subsystems and its solar electric propulsion system, which will keep the station in orbit around the Moon. PPE will also provide capabilities for high data rate communications between the station, lunar surface, and Earth. Several payloads will take off with PPE and Halo and collect scientific data en route to the Moon. ESA is contributing to 2 payloads that will measure radiation in Gateway's orbit. The European Radiation Sensor Array, or ERSA, will study solar wind. And the Internal Dosimeter Array, or IDA, which includes contributions from JAXA as well, will study radiation shielding and improve radiation physics models for cancer, cardiovascular, and central nervous system effects, highlighting crew health. Once in its polar orbit around the Moon, Gateway will be joined by a second habitation element, an ESA and JAXA contribution called the International Habitation Module, or IHAB. IHAB will launch on the SLS rocket at the same time as the Artemis 4 crew in Orion. IHAB will launch on the SLS rocket, Orion will act as a tugboat, bringing IHAB to the rendezvous and dock with the Gateway's Halo module. While 2 crew members stay on Gateway to continue setup, conduct research, and monitor ground activities, the other pair of astronauts will enter Starship and disembark to the lunar surface. Progress is well underway for all aspects of this complex Artemis 4 mission, with the SLS rocket, Orion spacecraft, and the ESA-provided European service module in various stages of development. Recently, the SLS payload separation system was installed on the Payload Adapter Engineering Development Unit. Fabrication and assembly of the PPE are also underway at Maxar Technologies in Palo Alto, California. The team recently completed assembly of the PPE's central cylinder and will place it through a series of tests to ensure the hardware's integrity for the future flight. The blue plume of the advanced electric propulsion system is shown here inside a vacuum chamber at NASA's Glenn Research Center in Cleveland during the recent thruster qualification testing. Additionally, Halo is one step closer to completion following friction stir welding in Turin, Italy at TASI. We anticipate Halo being shipped to the US later this year for final outfitting. An additional Gateway development was the recent announcement of a new implementing arrangement, which the United Arab Emirates will provide Gateway's crew and science airlock module. The airlock will allow the crew and science research transfers to and from habitable environment in Gateway to the vacuum of space. These transfers will support broader science in the deep space environment, as well as Gateway maintenance. Artemis 5 is NASA's 4th crewed mission under the Artemis campaign, and it's aimed at landing astronauts on the lunar surface to establish sustainable exploration. Artemis 5 will demonstrate the capabilities of a second human landing system, Blue Origin's Blue Moon lander, and a lunar terrain vehicle, which will provide the crew with access to more of the lunar surface for the collection of diverse scientific samples. In addition, Gateway will add on the ESA-provided Esprit refueling module and the Canadian Space Agency's Canadarm3 robotic arm. Here are several photos of Artemis 5 hardware in development. As you can see, the European service module for Artemis 5 is underway. In addition, the Aerojet Rocketdyne is making progress on manufacturing the first 6 RS-25, what we call restart engines, that will begin flying on Artemis 5. These new engines will cost about 30% less to manufacture and will operate at a higher thrust level than the current RS-25 engines. the first and second stages of the New Glenn rocket. Let me see if I have the right slide. Nope, I'll go back. There you go. Yep, the first and second stages of the New Glenn rocket, which will eventually be used to launch Blue Moon, were mated for the first time in January. And the rocket was turned upright in February in anticipation of the first launch later this year. Blue Origin will conduct a drop of the test of the Blue Moon Mk1 cargo lander in March of 2020, or did conduct it in March of 2023 at their manufacturing facility. The cargo lander will serve as an early pathfinder ahead of the launch of Blue Moon. In regards to the Lunar Terrain Vehicle, NASA is working toward an award date in early April to announce the selected vendors that will help develop it. And beyond Artemis 5, future missions will expand our ability to explore, conduct science, live and work on the lunar surface, in addition to a pressurized rover and habitation systems. I hope you'll agree that we live in an extremely busy and exciting time for human spaceflight. Artemis is different than anything humanity has ever done before. The Artemis campaign will bring the world along for this historic journey, forever changing humanity's perspective of our place in the universe. Ultimately, what we learn on the moon will determine humanity's capacity to live and work in deep space for extended periods, setting us on a path for our next giant leap, seeing the first astronauts to step foot on Mars. Again, thank you for the opportunity to share what we're doing on Artemis today, and thank you again for the generous invitation to be here.
Thank you so much. I know that you have a very busy schedule, and we're very delighted that you could come and be with us here in Luxembourg. I know your next event is to go and see the facilities in Bremen, so we wish you a very good journey, and thank you for being here with us in Luxembourg. Thank you again for those online. I've seen the notes coming in. It's great to have you with us online, as always, and naturally you can direct your questions to all of the next speakers through the chat online. The next session is Missions Past and Future, to reflect on the landmark missions and upcoming ones too. It will be moderated by Abigail Calzada-Diaz from ESRIC. You heard her talk yesterday, of course. And with that, please welcome Abigail to introduce this section. Thank you.
Thank you, Lisa, and welcome to the session of Missions, Past and Future. So our first speaker is Pierre Facop from the Exploration Company, and he's going to talk about the Exploration Company making space affordable, sustainable, and open. Welcome, Pierre.
Good morning, everybody. Thank you for the invitation and thank you for the organization. It's very, very nice. So I'm very happy to be with you to present the Exploration Company, what's our project. So first of all, as explained, we plan to offer solutions which are available, affordable, sustainable, and open. What does it mean? Available, it means that our space vehicle will be compatible with many launchers. So we call it launcher agnostic. We could fly with European, US, Indian, Japan launchers. It's very important to have this opportunity to offer a solution compatible with every launcher. We also want to be affordable. That means that we will present a price which is very reduced in comparison to the price of our competitors, and we target 25% price of our competitors. We also provide solutions which are sustainable. That means that our vehicle will be reusable and will be refuelable at the end of the day. And of course, we built our vehicle also to be open by using open sources and using open interfaces to offer a maximum of use of our vehicle. So before going more in details on our roadmap, who are we? Because perhaps everybody don't know who we are. The exploration company has been created less than 3 years ago now. We are gathering now more than 110 people, equally shared between Germany and France. In Germany, we are based in Munich, and in France, we are based in Bordeaux, with competencies equally shared in these two locations. And we have also decided to open a new location in Italy, because Italy is also a very main space country in Europe, and we will be located in Torino for this third location. We are growing very fast. We are gathering more than 65 million euros of fundings coming from private venture capitals. And we are already negotiate and won contracts. The most important one is the contract signed with Axiom Space last year in October. Axiom Space by a full cargo mission, so a full vehicle to go to his own station. The mission is planned in 2028. So it's a contract very important, because that's the first time that a US company signed a contract with a European company before our first flight. It's a contract of 150 million euros, and it shows the confidence of this customer in our company. So we have a roadmap based on different step-by-step approach with the goal to fly as soon as possible and as frequently as possible to demonstrate and to validate our capacities. Our first demonstrator is a pure technological demonstrator, which is called Bikini. It has been realized in 9 months in 2022. It will demonstrate our capacity to master the re-entry phase, which is a very critical phase, as you know, of a space vehicle, because as we plan to reuse our vehicle, that means that they will come back to Earth and we will need to master this re-entry phase. So that's the purpose of this first demonstrator, which is a small capsule of 60 centimeters and 40 kilograms. This capsule will fly in the next weeks, because finally it will fly on Ariane 6, on the maiden flight on Ariane 6, so it will come soon now. It was not easy to find a flight slot, because it's a very small object, so, but now it's okay, and we will fly very rapidly now. The second step of our roadmap is subscale capsule, as you can see on the screen, which is called Mission Possible. Mission Possible will offer the first commercial capacity, because we have 300 kilograms of payload, and we have already booked all this capacity with different consumers, and you can see on the slide the logos of these customers: ESA, CNES, and DLR, our I could say national and European Space Agency, buy some capacity on this vehicle, and Airbus also buy some capacity, and other customers, but I won't give the name of all, but it's all booked. What is the purpose of this capsule? Is again to validate all the capacities of our space vehicle, even our re-entry phase. So we'll recover the experiments which will be on board this capsule. This capsule will be launched in 2025, next year, on Falcon 9. The integration is now well advanced. You will see on the next slide. And we plan the environmental test, in June. So it will come very, very soon. After that, we'll integrate the different payloads of our customers before a flight during the first semester next year. And finally, we will deliver the full-scale vehicle, full-scale capsule, as you can see, with a capsule and a service module. The capacity is larger than the demonstrator, of course, because we have a capacity of 4 tons of payload on the uplink, and we will offer 2.6 tons of downlink from the space station or from space to Earth, because it's important also for some customers to recover their demonstration, their experiment back on Earth. We'll offer 2 use cases on with this vehicle. Either a free-flying use case on low Earth orbit, and the duration of the mission could be typically 2 months. Or we could also offer a cargo version, a cargo use case. That means that the vehicle will dock on the ISS today and in the future on the different private space stations, like the one of Axiom, as I mentioned before. So it's very important because we consider that there's really an important market on this cargo capacity. So that's why we are also proposing this capacity to ESA, because as you know, ESA has opened a competition for cargo capacity a few months ago, and we really we expect to be one of the winners of this competition. It's important, of course, for us. And for this cargo mission, we could imagine to be docked to the station during 2, 3, or 4 months. Depends the need of the customer. So that's our first steps for LEO Earth orbit. But we intend also to go to the moon, and it's close to the purpose of this conference. And we have a new mission which is called Terminal Moon. We plan to provide this mission in 2028. The payload capacity is, of course, less. It's 2 tons. And as you can see, we in fact provide a service module with a cryogenic propulsion system, which is fully new. And I will give you some more information about this propulsion system, which is under development. And we'll offer also an upper payload platform above this service module with deployment mechanisms to allow deployment of payloads on the moon. We don't target for this first mission a return from moon, and the capacity is 2 tons, with a price which is, we are targeting a price of 200 kilo euros per kilogram for this mission. We also plan to have a mission which offer a link with the gateway, which has been presented as one element of the Artemis architecture. So in this case, we will go and come back after that from the gateway. We still have 2 tons of payload capacity, but we have this capacity to come back. And in the future, we also intend to expand our capacity by offering a refueling capacity that will help us to have longer mission on space, or to provide refueling to other vehicles, for example, for the gateway. So that's in few words our roadmap. What could be the use case we could offer on the lunar surface with our vehicle? Of course, we could transport lunar rovers. We could also transport different capacities, different materials to allow in-situ resource utilization. We can also provide radiation measurement and shielding, and other different use cases you can see on this slides due to the capacity which is offered by the capsule. Few images on where we are. you see pictures of Mission Possible. So you can see that in less than 2 years, we have already, you see the mechanical structure of vehicle with different equipments inside this structure. This picture has been taken 1 month ago in our integration room in Munich. You can see also we have a hardware-in-the-loop platform on the left picture. You can see also a picture where we are putting a bonding on the, for the thermal protection and the shield. You can see also a picture of our onboard computer because we decided to do by our own onboard computer, and you can see also some picture of engine test in the DLR installation. That's the a picture of engine which is under development for the next moon vehicle, because as I mentioned, we are already working on this vehicle because, and we all know that propulsion is a critical path for the vehicle. So that's why we are already working on this engine since more than 1 year, and we have made some few first tests in DLR test bench a few months ago, as you can see on this picture, and so it helps us, of course, to stick at our roadmap. You will see that we have a regular so that's really amazing. So that's all. Thank you. As you can see, just to show you that we are really committed to fly very often to validate our development, to validate our engineering, and first flight will be in the coming weeks. So keep online. You will have the information on our different media, and I'm sure you will be interested to know what will be the next steps. Thank you very much for your attention.
Thank you for your presentation. Is there any questions in the audience? Okay, I have actually a question. It's like for the mission that you are planned for the lunar surface in 2028, are you considering some nice survival capabilities in your capsule, in your landing, or how long it could be operated in the lunar surface? For how many lunar days or Earth days?
I don't have precise answer on your question, but as I mentioned, the vehicle will stay on Moon, so it won't go back to Earth. Yeah. So no, I don't have any precise answer.
Yeah, well, I guess it's still pretty early to know about that. Another question is like, well, probably it's also very early stage about that type of mission. Is like, do you also have any kind of idea in which area of the moon would you love to land? If it's more in the poles, you will be able to land on the poles, or you are going to stay more in the mid-latitudes? Do you have any information about that?
In fact, it will really depend on what mission we will have to perform, and with which customer, for which purpose. So we have not yet defined precisely what will be, which area on the moon we will go. We'll see.
Okay, thank you very much. I really hope you success.
Thank you.
Thank you very much. So now we are... we are welcome off stage to Sofia Casanova from Ispace, where he's going to talk about Mission 2, the Ispace Europe's micro rover. Welcome, Sofia.
Yeah. So thank you, and thank you for having me here. The foundation of Ispace's vision is to expand our planet, expand our future. And it's an ethos that captures our collective ambition for exploration and innovation, and our drive to foster both a sustainable and thriving future for our planet. Our team of over 250 professionals spread across Japan, Luxembourg, and the United States captures our essence as a global innovator and our commitment to leveraging international collaboration. But it's here in Europe where we've identified a really unique opportunity to tap into this vibrant space community and work together to foster a new era of economic development and collaboration. And it's with that in mind today that I am proud to present Ispace Europe's micro rover. Designed and built by our incredible engineering team here in Luxembourg, this rover will be part of Ispace's second venture to the moon, currently positioned to launch at the end of this year. And in doing so, this rover is set to be Europe's first commercial lunar rover, carrying solely European payloads. And before we dig a bit deeper into this exciting adventure, pun intended, I'd like to take a moment to reflect back on where we were last year at Space Resources Week. As it was actually at that time that Ispace stood on the precipice of a really pivotal moment. Already in lunar orbit, our inaugural Hakutu-A mission was just a week away from attempting a lunar landing. And it was actually, in fact, during that conference that this stunning image was taken. An Earthrise, particularly special as it was taken during a solar eclipse, with the moon's shadow visibly being cast across Australia. If you come visit us at our booth, we've got some postcards of this image. Yeah, it's a pretty cool picture. So despite the mission not achieving successful landing, we did achieve many significant milestones, which afforded us some invaluable lessons that are crucial for our journey ahead. And the lunar quest continues. On to Mission 2. Mission 2 of the Hakutu Lunar Exploration Program will be building upon the experiences that we gained from Mission 1. It is poised to further validate our lander design and technology. In a tribute to our enduring perseverance, we have aptly named Mission 2 Resilience. The design of Resilience leverages the proven architecture and of its predecessor, incorporating a series of pivotal enhancements aimed at perfecting our lunar landing. However, it is not just about demonstrating technical feasibility, it is also about demonstrating commercial feasibility for lunar transportation and exploration. Significantly, Resilience will be the first commercial lunar lander to be fully manifested with commercial non-space agency payloads. Among the very payloads it will carry to the moon, it includes a water electrolysis equipment from Takasago Thermal Engineering, one of our Hakutu-A partners, a food production experiment developed by Euglena, a radiation sensor from the Department of Space Science and Engineering at the National Central University of Taiwan, and an alloy plate embodying the Charter of the Universal Century. And finally, certainly last but not least, the Ispace micro rover. Each payload is a key piece of our overarching goal to extend human presence and activity into space. But let's take a bit more of a look at that lovely little rover. Weighing approximately 5 kilos, its small, lightweight design makes it agile and efficient for small-scale lunar exploration. If you have not seen it yet, we have a 2-scale replica at our booth. I encourage you to go and have a look, talk to our talented team who will be happy to answer any of your questions. The micro rover was developed with funding from the Luxembourg Space Agency. Notably, the build of this rover has a strong economic footprint here in Europe. The design Manufacturing and assembly of our micro rover is taking place right here in Luxembourg at our Ispace Europe office. Our field testing is taken just across the border in France. Environmental testing was completed in Toulouse, and operation of the rover will be performed from our Mission Control Centre here in Luxembourg. And to give you a bit of a sneak peek of our rover in action, here is a short video taken from our lunar yard. So the rover is equipped with HD cameras for capturing high-resolution images of the lunar terrain. Designed with mobility in mind, the rover's uniquely shaped wheels allow it to traverse the regolith with precision. And we'll just take a moment to look at it scooping up some material. So now I did mention that we have 2 European commercial payloads on board. One, I can't currently disclose the name, but it is an artistic piece which will be deployed on the lunar surface by our rover. And the other is our regolith collection system, which you just saw being demonstrated there, an innovative shovel mechanism developed by our Hakutu-R partner, Epiroc, a renowned leader in mining equipment and infrastructure based in Sweden. We are very proud of our collaboration, which not only underscores the synergy between terrestrial industries and space exploration, but also highlights the significance of incorporating Earth-based expertise into our lunar missions. And my colleague Carlos Espejel will be presenting tomorrow and will go into a bit more detail about this partnership and the exciting plans ahead. Sorry guys. So this scoop, this shovel, not only tests our excavation capabilities, but will also allow for scientific experiments which can tell us a bit more about the regolith properties and characteristics, which will help lay the groundwork for future exploration. And additionally, it will actually perform another vital function during this mission. So in December 2020, Ispace Europe entered into a landmark agreement where Ispace was awarded by NASA a service agreement to procure lunar regolith and provide a legal demonstration of international legislation of space resource transaction, providing a critical step towards the commercialization of space resources. And for this test, we'll actually be using the Luxembourg legal framework for space resources, which we use to achieve this legal demonstration. Now, moving away just briefly from our mission, I also want to take the opportunity to discuss our services beyond transportation that Ispace can offer. At Ispace, we endeavour to be a one-stop shop for lunar exploration, offering end-to-end mission services. And this begins with mission planning and design. At Ispace, we bring a wealth of expertise to the table when it comes to lunar mission planning. Our services encompass a thorough analysis and evaluation of our mission concepts, ensuring that our customers, clients, partners' vision for space exploration is not only realised, but optimised for success. We offer services in mission development, crafting mission concepts, setting mission objectives, conducting detailed trade studies to optimise mission outcomes. We also do landing site selection, identifying, analysing, selecting optimal landing sites based on a variety of mission-specific criteria. And we also offer in-mission traverse and route planning with sophisticated visualisation and in-house built path planning tools. Our mission at Ispace is to empower our partners, our customers, with insights and strategies needed for ambitious lunar exploration missions. And at Ispace, we understand that the success of space missions hinges on exhaustive testing and meticulous planning. This includes testing and validation of our rover operations. We conduct comprehensive testing, simulating the lunar environment to validate our technology, our exploration tools, and scientific instruments. Testing in relevant conditions allows us to identify and address technical gaps, risks, and ensuring we're prepared for every eventuality. In addition to testing hardware, we also use our analog sites to test our operational procedures and our operators and ensure that our procedure and products are robust and streamlined to maximize operational output. And we use this time to identify and resolve limitations and craft workarounds when necessary. Now, I've discussed a little bit about Ispace Europe's micro-rover, but it is not our only rover platform. We are designing larger platforms to undertake more advanced analytical and exploration activities, which will be capable of hosting larger mass payloads. Ispace is also principally a lunar lander company, with our Series 1 Hakuto-R lander designed in Japan, and our Series 2 lander Apex-1, which will be built in the United States. Apex will fly in 2026 under the Draper-led CLIPS contract to the far side Schrödinger Basin, an intriguing basin of huge scientific importance and one deserving of detailed scientific analysis and a whole presentation on itself, but unfortunately I don't have time. But please come and chat with me if you'd like to know more about this mission. Ispace has 3 mission operation centres, one in Japan responsible for the Hakuto-R Mission 1, Mission 2 landers, Luxembourg Centre, which served as backup for Mission 1 and will be the rover operations centre for Mission 2, and a control centre which is being designed and developed in the US for the upcoming inaugural flight of the Apex-1 lander. Our missions use Europe's Space Operations Centre, ESOC, Mission Control Ground System Network, the first commercial entity to do so. Our current lunar missions are more than just proof of our technological capabilities. They are platforms for groundbreaking experiments that pave the way for advanced resource utilization. By integrating small-scale experiments and prototypes into these missions, we gain actionable insights that will fuel the acceleration of innovative and optimized systems. For us at Ispace, every mission presents a learning opportunity and a chance to conduct fundamental science, to get the data that we all need to inform our future in space, not just incrementally, but exponentially. And finally, our endeavours at Ispace extend beyond the physical aspects of lunar missions, and we delve into the analytical realm to provide comprehensive support in various forms, notably including resource modelling, estimation and classification services. And if you want to know more about this aspect, I encourage you to see Carlos's presentation tomorrow, where he will explain a bit more about these service offerings. So as I conclude, at Ispace, we are opening the doors for local industries and academia to partake in space exploration's next chapter. With our micro-rover development and preparations for the upcoming mission, we hope to lay the groundwork for a robust European presence on the moon. And I look forward to presenting new images at upcoming Space Resources Week, not only from our lander, but also from our rover exploring the surface. I thank you for your attention and can take some questions. Thank you.
Thank you, Sophia. There is any questions on the ground? It's like okay. It's like it's difficult to see with that light. Yeah.
Hello.
Hi.
So my name is Shivam Kumar Singh. I'm pursuing my master's in space technologies and business in the University of Luxembourg, and also a graduate student researcher in the SNT and Space Systems Engineering Research Group. My question is very simple. I wanted to know, like, out of these 6 services from Ispace which you have mentioned, how many of these operations would be carried out in Luxembourg? And what opportunities can fresh graduates expect from Ispace to take part in?
Yes, so all of those 6 services are offered here within Europe. They are will be tested and proven for our Mission 2. We have, I didn't actually explain that, but we have the 3 offices, so Japan and the US are responsible for our 2 series of landers. Europe is responsible for the rovers, and it is also where we house our science mission planning and ISRU activities within the division here in Ispace. For opportunities to work with students, academia, this is something that we really want to pursue. And yeah, I encourage you to come talk to us in the booth, and we can work out some really exciting opportunities to work together.
Any other questions? I have there is a question.
Yep.
Oh, great. Please.
Yeah, thank you very much for this great talk. So I'm wondering which geophysical method you want to use for to search for the resources for the resource estimation.
Yeah, so we've looked at, so we don't have any current planned missions, but we are looking with various partners that will go on our future platforms. So we've looked at ground penetrating radar, seismic, and a few other techniques. So for not only geophysical, but also techniques to analyze mineralogical, so spectroscopy type experiments as well. So a wide range to investigate the surface and the subsurface, and we're also developing our range of excavation tools so that we can also analyze that subsurface information using more direct means as well.
Okay, I think that we don't have that much more time for more questions, but yeah, I invite all of you that visit Ispace booth outside, and if you have any other questions, you can address. Thank you very much, Sophia. So, our next speaker is Arvind Ramana from the Australian Space Agency, that with a presentation title of Moon to Mars and Beyond. Welcome, Arvind.
Thank you, everybody. Am I audible?
Yes, yes, we can hear you.
Awesome. Awesome. So thank you so much for the opportunity, and I'm seriously regretting not being there physically, but I'll try to make the best out of this session. My talk is going to be on Moon to Mars and Beyond, leveraging cross-sectoral niche, and I'm going to talk about it from an Australian perspective of the mining and the resources sector and our strengths in the mining and the resources sector, and how we are trying to spin in those capabilities into space. Next slide, please. Just to give you a snapshot of the Australian space sector, and this was the numbers from 2021, slightly out of date, but still relevant. We had over 618 organizations with approximately 4.5 billion in turnover, 15,000 plus people employed in space and space-related sectors, with an average salary of approximately $100,000. It's not a huge sector, but growing and evolving as we speak, and we're excited to be a part of it, as part of the Australian Space Agency's role is for growing the sector and bringing in opportunities for our partners. Next slide, please. Here's where we talk about the Australian Space Agency's venture into space exploration. Our journey started approximately 4 years ago, and we started with a heavy focus on robotics and automation sector, because that's where Australia has really strong capabilities in. We have been strong players in the mining industry, and we have been strong players in the robotics industry. So it was an interesting overlap for us to understand how our capabilities in these industries can kind of spin into space and spin back to support better opportunities on Earth. And we try to identify niche capabilities here on Earth, such as remote operations, interoperability, analog sites, robotic platforms, ISRU, and foundation services. Australia has great capabilities in remote operations and building the glue layer for making systems interoperable, and we have been doing this for over several decades. We have amazing capabilities in robotics, navigations, and also skills in prospecting and extraction that translate directly with some delta into ISRU. So we also defined this term called foundation services. These were services that we termed as operational services that support exploration and large-scale exploration missions from our partner nations such as US, services with recurring demand, and that includes services such as monitoring, inspection, logistics and transport, remote maintenance, etc., which Australia is really good at doing here already on Earth for terrestrial applications such as mining. And it was our contribution to what would be the future Moon to Mars program. And this was our offering to our partners such as NASA and European Space Agency, where we could, Australia as a partner nation, provide some niche little capabilities that are critical for space exploration. Next slide, please. So one such example that started around the period of 2019-2020 was the Spark. It's basically Australia's space automation, AI, and robotics control complex. It was a unique example where in Australia, situated in Western Australia, talks to the intersection of space and the resources sector overlaps, where a company called Fugro, with the support of the Australian Space Agency and the Western Australian government, set up a remote operations center, right? Which, while it is also controlling remotely operated underwater and undersea robots who are laying cables undersea, also controlling massive autonomous mining trucks in our mines at Pilbara. At the same time, today, it's also supporting lunar landers from companies like Intuitive Machines and robots from other private players. This is a testament to Australia's strengths in remote operations on Earth, in space, and how to spin them back and forth. Next slide, please. And in 2020, our journey also began with the Moon to Mars program. We became one of the first founding signatories of the Artemis Accords. And from that was the initiation of the Moon to Mars initiative, or the Moon to Mars program, which we know today. It was a $150 million commitment to support the development of Australian technologies that support NASA's ambition for ongoing lunar presence and then move to Mars and beyond. We structured our Australian Moon to Mars program as 3 sub-programs or 3 elements: Trailblazer, Demonstrator, and Supply Chain Capabilities. Supply Chain Capability was a program that is currently allowing around 29 Australian space entities to mature their products for national and international customers. Demonstrator is a program to support Australian missions to gain flight heritage. And Trailblazer is a lunar rover program, which I'll spend more time on later today. Next slide, please. I'll talk a bit about the Moon to Mars Demonstrator program. So it was a $50 million program, approximately 11 projects, which we announced last year. A wide variety of projects from across the sector that are undergoing development and maturation as we speak. For instance, there is an experimental laser Doppler technology being developed by a company called Advanced Navigation in collaboration with Intuitive Machines. There's an ambient noise tomography instrument from a company called Fleet Space to support the mapping of the moon's subsurface characteristics. There is a quantum clock that is being developed, and there's even a little biological pod to demonstrate growing plants on the moon. We had a similar program in the past where we called it the International Space Investment Initiatives, where we had technology such as compression suits for astronauts to prevent muscle loss. There was also an AI companion robot developed by a company called Aiken, where the focus was about developing robots with personalities that can serve as companions to astronauts who are undertaking long distance travel for emotional security and safety. These are projects that are currently aligned heavily with Australia's critical technology priorities, but at the same time have strong links to the NASA Moon to Mars objectives. And also not to mention the spin-in and spin-off benefits for better life on Earth. These projects will bring in companies from adjacent sectors such as astronomy, AI, aerospace, and quantum into space, which is exciting by itself because we are trying to grow our sector with these cross-sectoral overlaps, strengths from adjacent sectors, and strengths from space that can be spun back on to the sectors where they originally came from. So these projects are undergoing development, and we at the Australian Space Agency are involved in defining the systems engineering processes for these projects. These are developed by the industry, and we are facilitating the industry with funding and support and mentoring to develop projects that are going to be in probably 2 to 3 years landing on the moon. And several of the previous opportunities that was discussed for ride shares to the moon, we have customers here in Australia who are looking for rides. Next slide, please. Of course, I'll move to the Trailblazer program. Trailblazer program, as I mentioned, one of the flagship programs under the Australian Moon to Mars initiative. It will leverage Australia's remote operations experience by developing a lunar rover, semi-autonomous, to perform sample collection, regolith collection, and return as a part of an ISRU demonstrator or a ISRU experiment with NASA. This mission will require performing several demonstrations for the first time for Australia, such as remote and semi-autonomous operations on the moon, operating in close proximity to other assets that have been launched as part of the NASA mission. And this will showcase our existing capabilities in a new environment, and it will provide a driver for Australian robotic innovations in space to demonstrate ruggedness and long-term operations on the moon, and thereby spinning in benefits back to Earth. Next slide, please. We call it Australia's boldest space adventure yet. The rover that I talked about, of course, this is just a pictorial demonstration of how the rover might look like. It may not look like this because as we speak, two Australian teams, Arrows and Yellow 2, these consortiums are actually competing against each other in what we call as Trailblazer Phase 1. They are developing the initial rover design, which we will evaluate and down select one entity who are going to be receiving approximately $42 million Australian dollars to develop their rover and launch and operate on the moon. So from an Australian Space Agency perspective, we set out objectives for our industry. We do not design the rovers ourselves, but we work very closely with our industry, and we are building in strong systems engineering processes to support our industry to become successful. We have set out objectives and we have set out level 1 requirements, and the industry solutions are actually being proposed as we speak to meet the Australian Space Agency's objectives in the Moon to Mars Trailblazer program. It is an exciting journey, and we are looking forward to it 2 to 3 years time for a rover to be developed and launched and operated on the moon in close collaboration with NASA, which is a learning experience by itself. Next slide, please. So these series of funded projects that I talked about have helped Australia and the Australian government kind of map our national capabilities across NASA's Moon to Mars objectives, Trans-Hab, infrastructure, remote operations, and science. Australia has some amazing technologies that fit into each and every one of these categories. And this is starting to gain recognition from our international partners as well, which is encouraging. And here I do have to shout out to NASA here because the work that NASA has done on the Moon to Mars architecture has helped countries such as Australia to define a framework to work towards too. And this is amazing, exciting, and challenging at the same time. Next slide, please. So where we are going out from here is bringing these benefits back to Earth. And we believe that we as an agency have just scratched the surface. We talked about overlaps with the mining and the resources sector, where Earth observations, connectivity, and to some extent even robotics overlaps between space and mining sector are well understood and well discussed. There are several other technology areas that are left to be explored. Innovations in areas such as dust mitigation, asset tracking, preparation, reclamation of sites, etc., could make human presence on the moon easier, sustainable, and much more efficient. And these are areas that we are starting to look towards and explore with our partners here in Australia. The way we approach this is investment in space can help fast track and supercharge a lot of these technologies from the mining sector and vice versa. And we are workshopping these conversations as we speak in various forums that we are involved in. Next slide, please. And another activity that we are currently undertaking is we released an expression of interest for the Australian space sector and the Australian mining sector to kind of collaborate to provide inputs on technologies that they are working on that is related to NASA's Moon to Mars objectives and the Australian Moon to Mars program. We received over 150 entries from our industry and academia and research sector in the last few weeks. And we are currently in the process of looking at the data and identifying further links. And this time we are trying to map it to the NASA Moon to Mars architecture. It is a learning experience by itself. We are learning about new capabilities in Australia that we haven't thought about so far as we speak. And we are excited to present the findings in probably the next year's conference, which we look forward to. Next slide, please. And this slide I've borrowed from ESA. The picture on, space for a green future indicates the direction we are moving in answering the questions on how space can support and increase productivity, reduce emissions, better support greenhouse gas detection, and making the mining and resources sector more efficient. So there are a lot of conversations to be had. This is just a starting point. And approaching space as a vantage point, as a place, and as an enabler for critical tech is a direction towards which we want to tie this all together. Next slide, please. And with this, I will stop. The world's largest space conference, IAC, is going to be held in Sydney in 2025 with a pretty relevant theme of sustainable space and resilient Earth. That's an ideal opportunity for the space and resources sector to get together and demonstrate use cases on how they have benefited each other. And we are looking forward to build those use cases along with our industry and our partner nations. And with that, I will conclude. Thank you for the opportunity again, and looking forward to present our findings next year.
Thank you, Arvin. I don't know if there is any questions on the floor. Please, if you have any questions, make a lot of movement, because between the light and my vision is really bad. Maybe I don't see you. So if you have any questions on the floor. Okay, actually, I have one, Arvin. It's Australia has a long tradition and history of mining. So I wonder if the Australian Space Agency is having currently any specific projects with one of these big mining industries that are based in Australia?
Absolutely. It's a great question. And I showed you the slide on two Australian companies, two Australian consortiums building the rover and competing for the next stage, right? Both of these consortium include big mining companies as part of their team. And the mining companies in these consortiums are bringing in the experience from remote operations into making these rovers better. And we also have several projects with companies such as Fugro. And I showed you the slide on the Spark, which is the remote operations facility. It was a project that was funded by the Australian Space Agency. And we are also trying to do a number of studies with our mining sector to identify more of these opportunities where we can start working together on.
Okay, thank you. Any other questions? Okay, thank you very much, Arvin. I hope that you have a good night, afternoon or night there in Australia. And yeah, hopefully see you next year, sorry. Okay, thank you.
Thank you so much.
Okay, our last speaker of this session is Robert Linder from ESA, and he's going to talk about the status of ESA's Prospect, EMS, and EMS LUPEX payload developments. Welcome.
Thank you. So I'm aware that I'm between, this presentation is between you and the next scheduled food uptake, so I try to be a bit concise. So I will give this little talk on behalf of the whole ESA project team and tech team as well, which has been working on these projects together. So, as you know, Prospect already mentioned yesterday as well in several presentations, is a package we have originally conceived for flight with Lunar 27. This, for obvious geopolitical reasons, will not take place anymore, but we had, of course, let's say, a warm welcome by NASA to provide this as a payload for one of the upcoming commercial lunar payload services missions, namely at the moment CP22, which has a notional, let's say, launch date of 26-27 at the moment, to be confirmed. So what are the goals of Prospect? Just to recap that, we are there to perform really cryogenic extraction of regolith samples from a depth of up to 1 meter with a drill, with an essentially instrumented drill as well. We are there to characterize the lunar polar surface and subsurface environment, and to determine the abundance, composition, and origin and chemisorpts volatiles inside the lunar regolith. We're demonstrating as well the in situ extraction of oxygen from minerals in lunar regolith within a small experiment we have implemented in the analytical package. Furthermore, the goals are to perform, as said before. So the handling and the interfaces is implemented. We have the landing at a latitude of cold locations, and the configuration and shadowing of payloads, sample handling, and instrument radiators is implemented. So to show a little bit the concept, we have a drill on one side, which goes down to 1 meter with multispectral imaging exactly at the borehole, so camera attached to the drill itself. Then we have the permittivity measurements and temperature measurements inside the borehole, as mentioned yesterday by Philip Reis. The preservation of volatile materials, which is quite a challenge in itself, from the point where we sample subsurface to the delivery to the analytical package to maintain the temperature is not easy, and it depends very much, of course, on the configuration, how you sit on the lander. And then, of course, we will provide the data concerning the subsurface material properties. So sample volume determination via multispectral imaging inside the sample inlet system. So there's an additional camera. And then, of course, the heating and sealing and heating of the sample will then provide you the volatiles, which we'll analyze with the analytical package. We are thriving in trying to get information about, of course, the content and composition and concentration of volatiles, but as well of the, let's say, isotopic ratio and fractionation eventually. So we have essentially, in order to achieve that, we have 2 mass spectrometers on board, one an ion trap, and another one really specifically targeting the isotopes is a sector field mass spectrometer. The status at the moment, for the drill, there's been cryogenic drilling already taking place in icy regolith in a thermal vacuum chamber. The transfer of the samples to the sample inlet system and then subsequent distribution to the ovens is successful so far, and on the engineering model level works. The solid inlet system consisting of funnels, a carousel with the ovens for the analysis, and a so-called tapping station, which is a nice piece of, say, fine mechanical engineering provided by Max Planck Institute, will provide us then, the access to the volatiles. And as mentioned before, imaging systems are available. So on the top right, what you see there is something I will elaborate later on, is already, let's say, the ion trap mass spectrometer. So to give you a little bit an idea how it looks like, I showed yesterday in one of the presentations the size of the whole thing, and that's integrated, let's say, inside the instrument box itself, together with the proximity electronics on top of it. Then the next activities we're working on, or actually, which has been already flying, is the exosphere mass spectrometer, which is part of the, let's say, peregrine ion trap mass spectrometer. And there, certain science objectives have been defined. We're monitoring the tenuous near-surface lunar exosphere in response to the natural and artificial stimuli, to characterize the exosphere after descent and landing and throughout the lunar day. That was the objective. study the release and movement of volatile species throughout the lunar day, because due to the thermal, let's say, variation, we will see, of course, some changes there. And eventually learn something about, as well, let's say, the postulated water cycle on the moon. Contribute as well the improved knowledge of the abundance and behavior for volatiles in general. To improve as well our understanding on the spatial and temporal nature of the lunar exosphere. So the science team is quite international. So we have NASA and European PIs, as well as a small group of US scientists outside of NASA. Key members are from Open University and RAL. And the ESA was as well directly involved as well in the operations and obviously as well in the technical development in terms of management and oversight. The whole thing has been essentially driven by NASA. Why is that so? Because we have provided this instrument essentially to NASA to get a free ride on Peregrine, on one of the first CLIPS missions, and I will get to that later. And of course, we're doing the data processing together. So here again, you see the mass spectrometer itself, then the whole, let's say, assembly with a box and the electronics. And on the right side, you see essentially the mass spectrometer with a white frame and the lid, the so-called wrapper, which has been provided by NASA as an interface to the lander itself. Some more eye candy in this respect. This is the Peregrine lander. And we are sitting, you can see it, let me see, here on this balcony over there. So that's our position where we are then, that was the idea, sit and sniff the lunar exosphere. So what has happened? As you know, we had a launch on the 8th of January. After 50 minutes, there was an anomaly, so there was quite a loss of propellant, and that essentially changed the whole mission scenario completely. I mean, due to the loss of propellants, the soft landing on the surface of the moon was out of question. The team has reacted very quickly, very swiftly, and has changed the overall, let's say, mission scenario such that we have a fly around the moon and come back to Earth, because essentially with the resources available, this was all what was possible. And then have a, let's say, rapid scheduled, this time, disassembly in the Earth atmosphere. So we were switched on, and actually compared to what has been envisaged before, just to have, let's say, instrument checkout and as well, do some measurements during the cruise, we actually transferred the overall, let's say, concept of operation and try to measure as much as possible during this fly around the moon and come back to Earth in order to see that the instrument is working and is, well, essentially sniffing the, let's say, metabolic products of the lander as such. So we had 8.5 hours of operation time. Everything worked essentially nominal in this respect. So we had a very successful flight validation of this instrument. And we were able to acquire 84 spectra with quite a good quality. So we had essentially 3 times more operation time during the cruise stage as such than originally foreseen. So if you look at the overall objectives of the instruments, the successful demonstration of the instrument, the successful acceptance of course, the instrument by NASA, very clear, and the instrument checkout in orbit, we have essentially achieved 90% of our, let's say, success criteria. The only one not to be underestimated, actually that's why we went for, is of course the successful measurement on the surface of the moon. But that was beyond our control in this respect. What's next? What's coming up right now in concrete payload, let's say, activities for lunar missions or scenarios is EMS LUPEX. This is a mission where we are actually reflying this spectrometer you've been seeing before with, let's say, higher accuracy and some more enhanced capabilities. So we really try to evolve and do step-by-step an evolution of the instrument with the JAXA LUPEX rover, which will hopefully land on the lunar polar environment. Currently, the status is that the contracts are signed. We'll have the kickoff actually this week of the activity. And hopefully we'll launch then the mission in 2027, of course. This is to be confirmed, as currently the scheduled discussions with JAXA are ongoing. And well, that's it, what I would like to present you on currently active implementation activities for lunar scenarios. There will be more to come. We are now currently working intensively within NASA, within ESA, and let's say with our stakeholders to define really a roadmap of opportunity payloads we can fly relatively quickly within a time frame of, say, 1 to 3 years. So these are essentially payloads which have already a significant TRL level achieved, which then can be fitted and, let's say, accustomed to certain missions or missions of opportunity which are coming up. And as we know, at the moment, there's a lot of things going on within NASA, within ESA, but as well other space agencies who are really wanting to go to the moon. And there will be probably slots to fly here and there. So thank you for your attention.
Thank you. Thank you. Is there any questions from the audience? Yeah, there is, I think there is one question back there.
Hi, Emma Cooney from ESRIC. Thanks a lot, Robert, for your presentation. I was just wondering if you could talk about any specific design aspects to account for the dust. You have a dust cover, and sometimes it's going to be open when you're taking measurements.
That's a very good question, and I don't know whether you had the opportunity to witness my presentation yesterday. This is obviously on the radar from us, the concern of dust. What you've seen in one of the slides was this carousel. Maybe you couldn't see it, but on this carousel we have the ovens. They are not, of course, completely out in the open. They are shielded by a baffle to some extent, so there is sort of a protection, but this will, of course, not completely mitigate the risk of dust. Dust is certainly something we're concerned about, and that's why we did these tests I mentioned yesterday to see how do these seals for the oven behave if they are contaminated with dust. Unfortunately, within the engineering, let's say, constraints we did not manage to find the mass, essentially, to implement active dust mitigation measures at this. Say, you could imagine some sort of a wiper or something getting rid of the dust. This is not in place, indeed, but given the experience we have in the labs, we are, say, mildly confident that even with a kind of significant dust contamination on the seals, we will be able to seal the ovens, for instance. Then when it comes to the mechanisms, they are, I think, sufficiently shielded, let's say, in terms of rotary joints, in terms of motors, etc., in order to ensure that dust is not an issue there. But it's certainly on our radar, very clear.
Thank you. Any other question? I have a really quick question. It's about the data obtained from these payloads. Yes. They're going to be available in the ESA Science Data Science Center, or
there is a, let's say, a working group, let's say a user group somehow, which is mostly trying to define and coordinate the science aspect of Prospect, for instance. Now specifically for Prospect, it's run by my colleague David James Heather. You may know him. And whoever is interested in his science is, of course, probably welcome to contact him and see what can be done. So in principle, it's an open forum of some extent. And when it comes to sharing the data, this will be organized, I guess, the same way as it's done for other scientific missions within ESA. Yeah.
Okay, thank you. So thank you very much for your presentation, and thank you to all presenters. A big applause for all of them. And yeah, thank you to all of you for being here, and I hope you enjoyed this session. Thank you.
And thank you to Abigail.
Thank you. Thank you.
It's lunchtime now. Thank you to all of you who are still in the room. We'll start again at 1:30, and the same to you online, back here at 1:30. Enjoy your lunch.